Today I kind of want to show how I go about making a gear in SolidWorks. So before starting anything on SolidWorks first, what I like to do is I like to use this Python program that I made that will basically give me all the values that I need for my specified gear that I want. So this here, all with comments, is just what the different parts of the gear are, what formulas I'm using, the invalid curve and stuff like that. And after that, I basically have a function called SpurGear, and I basically put in these four parameters: the module of the gear, the number of teeth on the first gear, number of teeth in the second gear, and the pressure angle. And putting these four parameters, I can basically calculate anything that I basically need to make a gear. So let's say I want to make a gear with the module of 1.5. I want, let's just say, I want 22 teeth. And let's say for the second gear, I want, I don't know, let's just say 44 teeth. And the pressure angle, I'll just keep it at 20. Let's say that's the parameters that I give for my gear. And once I run the program, so first I also get the images because I have imported the image function, and basically I made sure that it opens these two. These are basically sources that I got from YouTube, just learning from online, learning about involute curve. This is for a helical gear or a herringbone gear. This one's not really necessary for the spur gear, but I just have it there just in case. So once I did do that, as we can see, I have all the necessary numbers that I need to make this actually. So this part right here, I have all the necessary numbers that I need to make the gear itself. So at the very bottom two, that's the one that I kind of want to focus on. Those are the equations that I could use in SolidWorks to make the curve that basically generates the tooth profile. So this comes in very handy because I'm basically using equation driven curve to make these, and so it's much easier than actually trying to make it manually. Okay, so I'm gonna put all of this in the global variables in SolidWorks, and then I'm gonna actually make the spur gear. So I'm gonna put this in my second window. You guys will probably won't be able to see it. So here you can see SolidWorks. I'm gonna go to Tools, go to Equations. I'm gonna add some global variables. Now my module is 1.5. Let's see. My pressure angle is 20. Number of teeth, I'm gonna call this Z1. That's 22. My the pitch circle diameter is 33. My tip diameter is 36. My root diameter is 29.25. Then my base diameter is 30. Okay, so these are all the global variables I need. In my Python program, it does give the values for addendum, dedendum, the teeth depth, the clearance, all that stuff, but you basically just need these parameters to make the actual gear in SolidWorks. But it's actually a good thing to actually know about addendum, dedendum, and the clearance. I had to do a lot of research before I was actually able to do it in SolidWorks. Okay, so actually let's go about making a sketch, front plane, circle. So this will be my equals to the root diameter. Not the root diameter, sorry, the tip diameter, which is 36. Press OK. I'm just gonna extrude this real quick, 10 millimeters, that's fine. I'm gonna sketch on this plane. I'm gonna make 3 more circles. 1, 2, 3. Okay. So this will be my root diameter. This will be my base diameter. This one right here will be my pitch diameter. Oh, pitch diameter. There we go. Okay, so once I have these, I'm gonna go and make equation driven curve, and I'm gonna go parametric equation so that I have xt and yt. And I'm just gonna show you guys real quick again in my Python. As you can see, I have the parametric equations right here. So the top one is my xt and the bottom one is my yt. So I'm just gonna copy and paste those equations onto xt and yt. So xt I copy, paste, and I copy and I paste. So I'm just gonna go from 0 to 1. Yeah, that's actually 0.75. Why not? Alright, right about there. So as you can see, you can actually see the curve right there. That's going to be our tooth profile, and there we go. So now we have to do some. So now it's like mostly you have to be a little smart about how we actually do this. So first I'm going to go and connect this horizontal line to the root diameter, and then from there I'm going to connect from the root diameter to the base diameter. I'm going to make this a construction line for construction. Now I'm also going to make a line that is going to connect from here, and I need this to connect right over there. But right now it is showing coincident, but most of the time it does not. So what I'm going to do is I'm just going to make it coincident with the pitch diameter first, and then I'm going to control press this point and then this line right here, and I'm going to press coincident. This way I know for sure that it is exactly where I want it to be. Okay. I might want to make this a construction line as well. Yeah. Okay, now I'm going to make another line that is going to be connected from here till here. And now I'm going to get this angle, and this angle is going to be equal to 360 degrees, right? So 360, the whole circle, divided by 4 times the number of teeth, C1. Okay, it did not, C1. Hopefully it takes that. Okay, it did. So basically, I want it to be 360 divided by 4 times the number of tooth, because as you will see later on, this is only like the quarter of the tooth profile, not even half. Okay, so we still have like some mirroring to do and stuff like that. So okay, a lot of blue lines, you can make them defined, but we can make them defined, and I will. Let's see. I'll actually convert entities. Okay, this and this line, I'll make it coincident. Ooh, that might have messed it up. Okay, I'm not gonna make that coincident yet. I will make it coincident later on though. Okay, so for now, let's just try to make these defined. Okay, I'm gonna make a line from this point to this point right there. Okay, so it is defined. If it's not defined, make sure that this line and this line over here, they're collinear. So make sure they're collinear, and it will most likely will be defined. In this case, it was defined right away, but yeah. So I can't seem to do that, but let me control Z. Let me define this spot right here. From this point to this point, that is the distance I want. Okay. So So now if I try to move this, it won't move. Okay, but let's try to trim some entities. If I trim this, then everything goes away, and I trim this. Okay, so that looks good now, because I only want this part, right? I only want part here. I don't want it to extend out even more than it needs to. To make it defined, I think, yeah, all I have to do is that, and it's pretty much defined. Okay, and that is basically like a quarter of the work done. Oh, well, almost half of the work done. I'm gonna extrude cut this, up to next. Okay, now I'm gonna go mirror plane. I'm gonna mirror about that plane right there. Features to mirror, I'm just gonna say the cut extrude. Okay, so as you can see, this is basically like a cut, right? It's like a cut between two teeth profiles. So what I can do now is I can go circular pattern. Actually, before I do the circular pattern, I'm just gonna make sure that I actually have fillets. So one fillet right here and another fillet right there. 0.2 millimeters. Does that look good? 0.2, let's see. Nope. Okay, I seem to have chosen the whole face. Not the whole face, just the... Okay, 0.15. Yeah, that looks good. Okay. So I have the fillet. Now I'm going to do a circular pattern. Features to... So I'm going to choose the cut extrude, the mirror, and the fillet. And then the direction, I'm just going to press on the face of the circle, and it will basically be that. Now, how many of them do I want? I just want them to be Z1. Z1, meaning the number of teeth, right? And if I press OK, and here we go. We have a SpurGear. And if we look at this, the teeth profile are really good actually. And I have 3D printed them before, and they seem to be really good. So I'm basically using parametric equation and stuff like that to make this gear. Using the Python program like reduces your work by a lot. Using the global variables is like, it's the global variables in SolidWorks is basically a lifesaver, honestly. So yeah, that is how I kind of go about making SpurGear.